Welcome back to The Explainer. So if you've ever found yourself just staring blankly at a chemistry textbook, totally overwhelmed by all those endless categories of substances, well, you are in the exact right place. Today, we're going to build a crystal clear, top-down visual map so you can easily classify literally any type of matter you might come across. And honestly, more importantly, we're going to look at how to dodge those classic exam traps that seem to trip up students every single year. Here's our game plan for today's map. First up, the fruit salad analogy. Then, defining matter. Third, we'll tackle mixtures and exam traps. Fourth, the rules of pure substances. And finally, number 5, we'll test your knowledge. All right, let's jump straight into section 1, the fruit salad analogy. It's a relatable comparison to get us started. To really anchor these kind of abstract chemical concepts, let's actually start in the kitchen. Think about whipping up a fruit salad, right? You might toss in, say, 3 strawberries, a handful of grapes, maybe half an apple. Or, hey, maybe you double the strawberries because you love them. It doesn't really matter. It's still a fruit salad because the ratio can completely vary and every single piece of fruit keeps its own individual identity. Well, a fruit salad is exactly like a chemical mixture. Now flip that and think about a commercially bottled fruit juice. That juice demands a strict, fixed recipe every single time so it tastes exactly the same and keeps a completely uniform identity. That carefully crafted juice, that represents a chemical compound. Definitely keep this little visual in the back of your mind as we go. Moving on to section 2, defining matter, which gives us our scientific baseline. So now that our kitchen analogy is locked in, let's sketch out the very top of our classification tree. Per the formal NCERT terminology, matter is defined super simply as anything that has mass and occupies space. Just look around you right now. The water you're drinking, the air you're breathing, the pen you're holding to take notes, literally everything is classified as matter. This right here is the trunk of our tree, and from this point, everything branches off into 2 main categories, mixtures and pure substances. Next up is section 3, mixtures and exam traps. This is where we learn to navigate those tricky exams. Let's head down the left side of our tree diagram and dive into mixtures. Now, pay super close attention here because this is exactly where exams love to try and trick you. Unlike our super precise fruit juice from earlier, mixtures are basically just substances stirred together without a fixed ratio. You can add a bit more of one thing, maybe a little less of another, and guess what? It remains a mixture. Now, these mixtures are broken down into 2 distinct types. You've got homogeneous, which means they look totally uniform throughout, and heterogeneous, meaning they're totally mixed up and you can actually visibly see the different distinct parts. Now, take a look at this statement. Air is a compound because it seems uniform. If you take absolutely nothing else away from this explainer, please let it be this. This statement is a massive red flag. It is such a common student mistake. Look, just because something looks invisible or uniform does not magically make it a compound. Air is actually a homogeneous mixture. It's really just a bunch of different gases stirred together without any fixed ratio whatsoever. You know, understanding exactly how tests are going to try to trip you up is half the battle, and you really need to watch out for this classic NEET exam trap. Test makers love to disguise mixtures by using the word solutions, and then they'll ask you if those solutions count as compounds. The answer is absolutely definitively no. Think back to our rule. The composition of a solution can vary. You can dissolve a single teaspoon of salt in a glass of water, or you could dump in a whole tablespoon. It's a solution either way, which means by definition, it's a mixture, not a compound. And that actually brings us to a really brilliant example, brass. Brass is an alloy made up of copper and zinc. But because the ratio of copper to zinc isn't fixed, like you can tweak the amounts to make the brass harder or softer depending on what you need, brass is a homogeneous mixture. Since it's an alloy, it doesn't qualify as a true compound. A true compound would absolutely demand a mathematically strict, completely fixed ratio. All right, on to section 4, the rules of pure substances and their homogeneous composition. Let's leave the chaotic, totally variable world of mixtures behind for a second and slide over to the right side of our tree, pure substances. Pure substances have one absolute defining rule. They strictly maintain a homogeneous chemical composition throughout. They have one fixed identity everywhere. So pure water is always H2O no matter where in the world you find it. And this category splits downward into our final 2 classifications, elements and compounds. Let's look at how this builds the absolute bedrock of chemistry. Elements are the purest of the pure. They literally cannot be split into simpler substances by any chemical means. Compounds, though, they can be broken down into elements. But, and this is a big but, only at a strict fixed ratio by mass. If you mess with that mass ratio even a little bit, boom, you destroy the compound. This strict, unyielding mathematical relationship perfectly sets the stage for what chemists call the law of definite proportions. And finally, Section 5, test your knowledge. Let's see how well you can classify matter.
Okay, we've built out the entire map. You've seen the definitions, you know the rules, and you've seen the exam traps. Now it's time to put this brand new classification tree to the ultimate test. I want you to actively practice classifying these 5 specific items: seawater, brass, distilled water, soil, and carbon dioxide gas. Take a quick mental pause here. Which of these are elements? Which are compounds? What about homogeneous mixtures or heterogeneous mixtures? Keep those rules we just talked about fresh in your mind.
All right, let's see how you did. Here's the final breakdown so we can get some instant closure. Seawater, that's a homogeneous mixture. It's salt and water, and the ratio can totally vary. We already went over brass. Since it's an alloy, it is also a homogeneous mixture. Now, soil is a heterogeneous mixture, mostly because you can easily spot the different rocks, the dirt, and all the random organic matter mixed in there. Meanwhile, distilled water and CO2 gas, those are true compounds, bound by strict, totally unchangeable chemical recipes. So now that you can confidently classify the physical world using this top-down map, I really want to leave you with a final thought to chew on. We know that compounds, like water, are locked into a strict recipe, right? So consider this. How will the strict mathematical rules of the law of definite proportions change the way you look at every single drop of water you drink from now on? Just knowing that the exact ratio of hydrogen to oxygen by mass has remained constant since the literal dawn of the universe? I don't know about you, but it certainly makes a simple glass of water feel a whole lot more profound. Thanks so much for joining me in this explainer, and remember, keep questioning the matter around.